So the elements in node A, that means everything outside A, which will basically be everything outside A will basically be this numbers here and this numbers here. So that will be 1, 4, 5, 6, and 7. Remember, these are elements. What we have here are elements. They don't represent number of elements. And then part B of this question seems like it's a mistake here. This represents part B. So find the number of elements that are not in common between A and B. So that means everything outside the intersection of A and B. So everything outside the intersection, this is the intersection of A and B. So everything outside the intersection of A and B will be that, that, and that. Okay? So that's what that means. Everything outside the intersection of A and B. And if we just count, here remember that represents the number of elements. So we just need to count the number of elements. We have 1, 2, 3, 4, 5, 6, 7, 8. So 8 elements. And we can take that out. Okay. And then the next part of the question, find the elements in, and here basically remember here we are combining that and that. Yeah. Um, Instead of working through the whole thing together, we can work out the first part, find those elements, and then the second part, find those elements, and then we combine them together. So the intersection of A and B will be these elements here, which will be 8 and 9. And then outside A or B, yeah, which is outside this, will be 1, 7, and 4. So 1, 7, and 4. And that's it. So instead of sometimes just looking at the whole expression the way it is, those symbols and all that, uh, depending on what you have here, you can just think about each of these and then you combine them together. All right, so the last question here, um, it's just a logical question. So there's nothing in common between A and C, but these are the elements that you get when you combine B and C together. And then the number of elements in C are 3. So the elements in C are 3. So just by inspection, we can see that uh, let's start with this condition. A and C have nothing in common, which implies that 8 is in A, 9 is in A. These two cannot be in C. Otherwise, A and C will have something in common. Yeah? And since C has 3 elements, and when you combine B and C, you get these 3 elements, then it means these 3 elements should be in C. Yeah, remember here you've just combined the two the elements in the two sets. So which means the elements in C will be 5, 6, and 7. Number 14, we have this Venn diagram. And the question here is find, now here remember this represents the number of elements. So these are number of elements. So find the number of elements that are outside A and B combined. So this is A and B. So A and B are these two circles. Yeah. So what's outside A and B combined will be 4 and 8, which means, and this is the number of elements here, 4, and here 8, so that will be 4 plus 8, which will be equal to 12. And then in the second part, um, we are required to find the number of elements that are not in A or C, but B. So basically this means not A or C, but B. And this implies just B. So we are just interested in the number of elements in just B. So not A or C, you can see, not A or C, not these two, but just B. Yeah, and that will be 7 elements, as you can see here. And then the last part here on the Venn diagram, shed the region that represents A or B. So A or B is that, and C. So basically we want the region that intersects these two guys here and C. And that region will be this one here. Yeah. So that region um, uh, is the one that intersects when you you look at the overlap. Just look at the overlap of A or B and C, and that overlap is basically what's required. Okay, um, moving on to number 15. So the Venn diagram shows the universal set and 3 sets. So the first question is to find the number of sets in A or B. So A or B will just basically be this circle and this circle, and you're combining this. So that will be 7 plus 6 plus 3 plus 2, which will be equal to 18. Now the number of elements, this is part B, number of elements outside A will be 3 plus 2 plus 10, which will be 15. And then this means the number of elements that are just in B. So just in B, but not C. So in this circle, but not in that circle, will be 6 plus 3. So that will be 6 plus 3, which will be 9. Now, here we are looking for not A or not B. So not A, that means everything outside A. Not B means everything outside B. So that means everything except 6. Because everything outside A will be the whole of that region outside A. Everything outside B will be the whole of that region. And you're combining this. So that will be 7 plus 3 plus 2 plus 10, which will be equal to 22. Okay. Last question. The Venn diagram shows a universal set, and we are given the number of elements as, in the diagram. So the first question is find the number of elements that are in A or B. So A or B basically will be this circle plus that circle, and that will be 2 plus 4 plus 3 plus 6, which will be equal to 15. Number of elements that are not in B will basically be all these guys here. So that will be 2 plus 4 plus 7 plus 10, which will be equal to 23. Now, for this last part, part C, or not yet the last part, but for part C, we have just A, or A but not C. So just A will basically be 2, because this portion, A but not C, so just A, so this portion here, so that will be 2. Now for the last part, this part here, we have shown, if you look through the explanations that I've given previously, this notation here, so the intersection of not B and not C is the same as not A or C. So this is a true statement here. Yeah, you can look at my previous videos. It's implied in one of those questions that I've worked through. So this is a true statement. So you can use this to basically work out part D. So because it's easier to apply this in this problem than apply that. So here you're just looking at everything outside B or C. And if you look at everything outside B or C, will just basically be 10 and 2, which will be equal to 12. So that will be equal to 10 plus 2, which will be equal to 12.